Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. This time, let's illustrate the limit theorem for a power of a function. After understanding the limit theorem for the product of a function, of course, if we are going to proceed with multiple products, we are going to touch powers, specifically squares, cubes, etc. So let's try to talk about the process of understanding how is the power of a function will work under the understanding of limits. Let's try to come up with examples here. Let's say f of x is equal to x, and let's say g of x is 2x, and h of x is equal to x plus 3. Let's have these examples here. And if we are going to have an expression similar to this, the limit of f of x as it is being raised to an exponent, let's say p, any integer p, okay, integer, again, let's talk about integers, as x approaches to c, this is just equivalent to stating that we are just going to square, or subject the entire limit of just the function as x approaches to c to the same exponent. Or at the same time, if we know already the value of the limit of this, let's say the limit of f of x is equal to L, okay, the limit, sorry for that, let's have, and how about the, as x approaches to c, and we have the limit of g of x is equal to m as x approaches to c, and the limit of h of x as x approaches c is equal to n. If we know the limit of f of x, we simply have L to the power of p. Before we have an example, let's try to solve for the individual limits of our functions here. So limit of f of x, that's x, as x approaches, let's say -1. This is a limit of an identity, so the answer is -1. Then what about the limit of our g of x, which is 2x, as x approaches -1? This can be written as the product, the limit of the constant 2 as x approaches -1 times the limit of x as x approaches -1. The limit of the constant is the constant itself, so 2. The limit of an identity is the value of c times -1. You have -2. And we also have the limit of a linear function x plus 3 as x approaches -1. By the way, we are applying here the previous theorems. And if you have that, we can simply substitute according to the limit theorem for linear function. You have -1 plus 3, which will give us 2. Okay, so this is equal to L. This is our M, and this is our N. Now let's have an illustration here for this limit theorem. What if we have the limit of x squared as x approaches -1? Of course, this is very easy to understand because we can just automatically substitute. But to illustrate this theorem, of course, we can simply put this into perspective. Limit of x as x approaches -1, and you have the square of that. Okay, this is the limit theorem for a power. If you have a power here for a function, you take the simplest form of the function and you have your power after you solve for the limit. We know that the limit of x is -1, so this is actually -1 square, which will give us +1. Take note, if you're going to use direct substitution here, you will have -1 squared, which also equal to 1. Okay, now again, this is very easy to understand because this is very simple. Now let's proceed to the next few example, which is, I think, is also easy. What if we have here the limit of the cube of 2x as x approaches -1? Now for some of us, we can write this into, or we can express this. You have 8x cubed, right? This function, we can rewrite this as the limit of 8x cubed as you apply your laws of exponent. and you can substitute -1 here right after. But we can just simply apply the limit theorem here which tells us that if we have already computed the limit of 2x, as we have here, this is the limit of 2x earlier, -2. Simply use that. You will have here the limit of 2x as x approaches -1, and you cube that one here. In short, again, you will have the result -2. So we have the cube of -2, which is -8. Again, by direct substitution or by applying the laws of exponents in this manner, we are showing you the all different methods so that it's up to you later on which you will follow. Okay, but we are illustrating each of these theorems that you have your options. So if you have this, you have applied your laws of exponent and you apply here the direct substitution, you have 8 times -1 cube. You have 8 times -1, which is -8. Same as well here. Okay, let's have the last one. What if you have the limit of x? What was that? H of x, x plus 3. This is where it gets complicated now. X plus 3 and you raise to 7. Okay. If you have something like this, this is where this limit is very appropriate to be used, because in the earlier examples like x squared, like 8x cubed, you just simply applies direct substitution, or the idea of loss of exponent before direct substitution. But here, okay, of course you can apply direct substitution if you would like to, but of course it's the exponent of 7. Okay, so what we could do here is write it like this: limit of x plus 3 as x approaches -1 raised to 7, because we already have the value of this. The value of that, going back here, you have this result 2, positive 2. So you will have the result here of 2 to the power of 7, which will give us 128. Are we right? We have 2 to the power of 6 is 64, or 2, 4, 8, 16, 32, 64, and 128. Again, you can even use direct substitution here if you would like to, but again, we have shown that direct substitution may not work for some. We had a video for that. Direct substitution of c may not be similar to what is really the limit. So to be safe, you can apply these limit theorems. Of course, you will have the same result as here. So this is how we illustrate the limit theorem of our power of a function and its relationship to other limit theorems. So what are you waiting for? Subscribe now!